Alright, so here we're talking about 4.1.3 multiplying radicals. I've got the rule. When we don't have a coefficient, the square root of a times the square root of b is the square root of ab. A root b times c root d. We multiply the outside and we get AC. We multiply the inside and we get dd. Okay, the saying that we say for multiplying radicals is multiply the outside and then multiply the inside. That's step one. Step two would be to simplify. If you haven't written that down, write that down. Your last thing before you circle it and say that this is the answer is you must simplify all answers. Okay? Alright, so here's some very basic examples. The square root of 3 times the square root of 2. There is an understood 1 to be in front right there, but what's 1 times 1? 1. So you don't have to deal with it. It's not nothing. Don't say, you know, that there's a 0 out there. There is a 1. You just don't have to worry with it. Root 3 times root 2 is simply root 6. Now, let me touch on something that that we talked about yesterday. Yesterday, when adding and subtracting radicals, they had to be alike. Right? They had to be the same. The object of the radical had to be the same. Is root 3 and root 2, are those like radicals? No, they're not. Were we able to multiply? Yes, write that down. You can multiply unlike radicals. When you're adding and subtracting, they got to be like radicals. When you're multiplying, they can be unlike. They can be alike, but they also can be unlike, and you still multiply. And that's true in algebra as well, right? What's 5x times 6y? 30xy. They don't have to be the same base when multiplying, right? You can multiply anything. Adding and subtracting, they got to be the same base. All right. How about 4 root 5 times 7 root 3? What's our saying? Multiply the outside. What's 4 times 7? 28. Then we multiply the inside. Root 5 times root 3 is the square root of 15. Last thing is to simplify. Does the square root of 15 break down? It does into 5 and 3, but you don't have any pairs. So does it simplify? No, it doesn't, and you're done. Right? 28 root 15 is your final answer because it doesn't simplify. Okay? How about root 8 times root 2? Multiply the outside, you just get 1. So you don't have to worry about it. 8 times 2 is 16. Would you get any credit if you wrote root 16 on a quiz or a test? No, because it can be simplified. The square root of 16 is 4. Okay? Questions? Any questions on this? Alright, before we move on, I want to kind of show you a trick. I want you to pay attention. The square root of 2 times the square root of 2 equals what? Square root of 4, which is what? 2. The square root of 3 times the square root of 3 equals the square root of 9, which equals, do you see a pattern? The square root of 5 times the square root of 5, can you skip this step and go straight to the answer? What is the square root of 5 times the square root of 5 equal? 5. This is helpful when you have a big number like 142. I don't have to multiply out what 142 times 142 is. This only works when they're exactly the same. The square root of 142 times the square root of 142 equals what? 142. And then I always use this example. The square root of a red brick times the square root of a red brick equals what? A red brick. What that's showing you, it's just algebra. What that's showing you is that as long as, write this down, as long as it's exactly the same, what you're getting, guys, is you're getting right here, you're getting the square root of 142 squared. The square root of 142 squared, the square root and the square cancel out, and you just get 142. It's skipping a step. Now, when is the only time that you use that trick? When they're what? Exactly the same. They have to be exactly the same. The square root of 7 and the square root of 7 equals 7. You don't have to say the square root of 49 and then say 7. You skip that step. It's just a little shortcut that may make it a little easier. All right, questions? Any questions? All right. Let's do some more multiplication. All right, here we go. I'll work it out. Multiply the outside. 3xy times 2x is 6x squared y. Yes? Is that right? Multiply the insides. The square root of 12 times 2 is 24. X squared times x is x cubed. Y times y squared is y cubed. Now you may be a little unshaky on exponent rules, so let's talk about that. X times x squared is x times x times x, right? That's just x times x. So how many x's do you have? You have 3. If you remember from your exponent middle school days, if you multiply like bases, what do you do with the exponents? You add them. Okay, and that may or may not have been covered in middle school. You may be a little rusty on that, but our exponents are going to be fairly small, so there shouldn't be that big. All right, so we multiply the outside, we multiply the inside. Now what? Simplify. Take a 2 out and you got 12. Take a 2 out and you got 6. Take a 2 out and you got 3. Got a pair of 2s. That's going to come out. It's going to turn that 6 into a 12 on the outside. On the inside, you've got this 2 and 3 lonely. That's going to be on the inside. So that takes care of that and that. All of that's taken care of. Then you have x cubed. That's x, x, x. A pair of x's is going to come out and make this x cubed on the outside. That takes care of these two. This x right here is going to be left on the inside. That takes care of that x. Then you got y, y, y for y cubed. You got a pair of y's. It comes out and turns that y into y squared, right? There's only one y there. When I bring a y out, it makes it y squared. This y stays right here because it's a singleton. It's by itself. Okay, raise your hand if you got that one right. Okay, outstanding. You got it right? Okay, good. Questions? Anybody have any questions? That's about as difficult as it's going to get. The only other thing that you might see, you won't see it on the test, but let's quickly talk about this. What's going on here?
Distributive property.
Outstanding answer. We've got a radical times a binomial, right? We distribute here and here. We'd get 3 root 2 plus what? Root 10. Write that down. Put that example in your notes, and that's all I'm going to basically say about that. The distributive property is exactly what you're doing there. You multiply just like you multiply outside and inside. You do all of that the same. Just have to be careful. We're going to talk more about the distributive property when we get down to polynomials. Okay? Questions? Any questions on that? Alright, I'm stopping the movie now.